The kidneys remove waste and extra fluid from your body. Kidneys can become damaged from a physical injury or a disease like diabetes, high blood pressure, or other disorders. High blood pressure and diabetes are the two most common causes of kidney failure. Kidney failure does not happen overnight. The process of dialysis is then done to filter waste materials from your blood. A dialysis machine consists of a series of membranes that function as filters and a specific liquid known as dialysate. The dialysate fluid filters waste materials from your blood, which are then transported via membranes. The dialysis fluid is pushed out of the dialyzer, and the filtered blood is returned to your body through a second needle. Two thin needles will be placed and taped into your AV fistula or graft. In dialysis, a dialyzing fluid is used which has the same composition as blood. Only waste substances will move from blood to the dialyzing fluid. This happens because both of the fluids are isotonic. If we put a hypertonic or hypotonic solution as a dialyzer fluid, it will affect the composition of blood. When we place an isotonic fluid, glucose and other salts do move, but their net movement is zero. When solution is hypertonic, glucose will move to blood, causing hyperglycemia, and when we use a hypotonic solution, glucose will move from blood to dialyzer, causing hypoglycemia. Only small molecules like water, nitrogenous waste, and electrolytes can pass through the tube walls, which operate as semi-permeable membranes. Water and solutes migrate from higher to lower concentrations during filtering via osmosis and diffusion. Also, since blood is isotonic, putting a hypotonic solution as a dialyzer fluid can cause the cell to go under cytolysis, which means animal cell death, in a hypotonic solution. Since the concentration gradient is high outside of the cell comparing to the inside of the cell, and the trigger pressure is high inside of the cell because water will rush inside the cell, causing it to explode. Moreover, putting a hypertonic solution as a dialyzer fluid can cause the cell to go under crenation, which means animal cell death in a hypertonic solution. Since the concentration gradient will be high inside of the cell compared to the outside of the cell, the water will come out of the cell, causing it to shrink and die. Furthermore, there are two types of dialysis, peritoneal dialysis and hemodialysis. The biggest difference in hemodialysis versus peritoneal dialysis is that hemodialysis requires an artificial kidney machine to filter blood. Blood is sent from an artery to that machine, and after filtration, it is returned to the vein, while peritoneal dialysis does not. Rather than using a machine, peritoneal dialysis uses the lining on the inside, called peritoneum, of the belly as a natural filter for blood. Blood plasma and dialyzing fluid are isotonic in terms of sodium. That's why there will be no net diffusion of sodium from blood plasma to dialyzing fluid. As you can see in the chart, the blood plasma has a higher concentration of urea as compared to the dialysis fluid. Hence, urea will diffuse out of the blood plasma, leading to the decreased level of urea in blood, which shows why the composition of the dialyzing fluid should comparatively be the same. Overall, this course helped me better understand the different types of solutions in the dialysate fluid and how important it is to match its composition to blood when doing the dialysis process. This is because putting the wrong solution can lead to crenation or cytolysis.